Here's my compass motor with a whole bunch of electronics added onto the top right up here. And that is an 8x8 LED matrix, another Arduino, a 9-volt battery, and right there is an accelerometer. So what happens is that the accelerometer senses the acceleration outward, the centripetal acceleration of the motor. And it's not connected to the motor itself, the motor control itself. But you can see the lights go on the LED because it's turning very slowly. And then as it slows down, the lights go off. Let's see if I could get it going a little faster. See, as it accelerates, more and more lights go on. So the idea of that was to somehow have it self-regulate the motor, but I haven't quite got there yet. But I'm going to show you that when the motor is going around 100 RPM, the acceleration, according to my math and physics, is going to be about 0.7 Gs, or gravities, which is about maybe 7 meters per second squared. 7 meters per second squared. Acceleration is measured in meters per second squared, or miles per hour squared, or miles per second squared, or feet per second squared, however you want to do it. So I'm going to start the motor, and you'll see when we get up to about 100 RPM, this LED matrix will be about maybe 3/4 or more lit up. Now, the idea is to have the motor somehow self-regulate. Now, it takes a little doing to get the motor started. All right, now the motor is going and in phase. Now you can see there's about 3 rows of lights lit. Now let's speed up the motor a little bit, gradually. So I can basically get the motor to start up. I might have to put a slower geared motor on there to get it to start up better. So you can see right now it's doing about 100 RPM. And you can see all those lights that are lit. So the thing is, if it went out of phase, let's say the motor had a load on it, and the load was enough to make it go out of phase, which I'm creating by friction. So the motor is out of phase, and it will suddenly slow down quite a bit. So the idea would be for the accelerometer to be hooked up to the controller on the motor, and if the motor slowed down all of a sudden, the accelerometer would adjust the speed of the electric motor, the N20 motor that turns the magnets, and that would restart the motor or resync it. It's not a matter of the motor being in phase. Once the motor is in phase, it will tend to stay in phase. But once it gets out of phase, it won't go back into phase. So The trick is getting it started and keeping it in phase, because sometimes it will go out of phase when it's running at a high speed. So, and of course, this is a compass motor. If you're not familiar with it, I would imagine most people watching would be familiar with it. And it's a bunch of magnets on an electric motor, and the magnets stand still, but the rest of the armature of the motor turns, because the magnets act like a compass, and they have torque against the Earth's magnetic field. So let's get it back up to about 100 RPM. That should be about 100 RPM. So you could see, watch if I go too fast. Now it's too fast for the accelerometer to gauge. At this point, I would have to recalibrate it. But it will go much faster, but you can see it's going to go out of phase soon. And now watch, as soon as it goes out of phase, you're going to see those lights go out. See those lights start to go out? So that would tell it it's out of phase, maybe tell it to stop and restart from going slow. So that's what I want to say today. Give me a like, a rumble, a subscribe, and stay tuned.